Dear listeners, welcome to Smart BCAD video tutorials. Today we are going to design a transformer-based 5V 500 mA point charger with a ripple factor of 4%. The circuit is already drawn as you can see. We have a transformer at the transformation side. We have a bridge rectifier with 4 diodes. We have a filter capacitor and an IC regulator 7805. So at the output, we have a voltage of 5 volts and 500 milliampere current. Now to start the design, we have to work backwards. By working backwards, what I mean is we are going to find the value of the voltage at the secondary side of the transformer. Now since our output is 5 volts, it means that a voltage of at least 5 plus 2, which is 7, has to be present at the node of C2. That is here at this node. Let's call it node A. The voltage at node A has to be at least 7 volts. Now, if we trace the line back again to this rectifier side, since at any time 2 diodes are conducting, because we are in positive half cycle, two diodes, diode D1 and diode D3 conducts, and during the negative half cycle, D2 and D4 conducts. So at any time there is going to be a drop of 1.4 volts. At 1.4 to 7, you have 8.4. So a 9 volt transformer, or the voltage across the secondary side to be 9 volts, is sufficient for our design. So for the transformer, we can say we only need 220/9 volt transformer, and the current, since the current at the output is 500 milliamp and it is the same current throughout the line, so the transformer, for tolerance, we can choose 750 milliamp current transformer. Now for the rectification side, we have 4 diodes which are all of equal value. So D1 equals to D2 equals to D3 equals to D4. We are going to use the diode IN4001. So the filtration stage, we have ripple factor given as 4%, which is equivalent to 0.04. Now for a bridge rectifier, the expression is gamma equals to 1/4 root 3 FCRL, where F is the input frequency, which is 50 Hz, C is the filter capacitor, and RL is the load. So F is 50 Hz. Now RL is the load voltage by the load current. So the load voltage, remember, is 5 volts and the load current is 500 milliamp. So do the calculation and we have 10 ohms. From this equation here, if we make C to be the subject of the formula, we have C equals to 1/4 root 3 FRL times lambda, which is 1/4 root 3 times 50 times 10 times 0.04. potential minus 3 farad, which is 7,200 microfarad. So C1, that is the filter capacitor, is 7,200 microfarad. So for the regulator side, where we choose the IC to be 7805, 78 series IC produce a positive voltage, and the index here, that is a 2 digits, signify the amount of voltage that the IC allowed to pass. So for 7805, this means our output voltage is a positive 5, C2 and C3 as specified by the manufacturer of the ICs, and C2 is given by 0.01 microfarad and C3 is 0.33 microfarad. So to design this charger, all we need is a transformer, 220 9 volts, 750 milliamp rating, and we only need one. We need diodes IN4001, phone number. We need IC 7805, and we need 3 capacitors. That is the filter capacitor and the 2 regulator capacitors. We need 7,200 microfarad. We need 0.01 microfarad. Lastly, we need 0.33 microfarad. So you can hit the market and buy this component and follow the circuit connection here, and you have your charger that produces 5 volts and 500 milliamp.